In this task, we have to simulate the circuit of charging and discharging a capacitor that should be also built in the lab. We are using Multisim. First, build this circuit. This switch is an SPDT switch. SPDT. Of course, you have to rotate it in order to get this layout. Also, the capacitor here is rotated. I've taken these values, 100 k ohm resistor and 470 microfarad capacitor, because these are the values available in our lab in the campus. Now we are using this switch to move between charging part and discharging. Now we will start by studying the voltage changes while we are charging. So let's take a voltage probe across the capacitor with a reference point. Now our switch should be on this position. When we are closing the switch on this position, we have here a path for a current to flow until the capacitor is fully charged up to 12 volt. Now let's split our screen. Here is the graph and here is our circuit. Remember a very important point: to click here on document, then come here to initial conditions. Make sure it's chosen as user defined. So again, before you start your simulation, click on document, initial conditions, user defined. Now let's start our simulation. We studied in theory that the total charging time is 5 times tau, and tau is R times C. Here we have R 100 k ohm and C 470. So tau is 47 seconds and the total charging time will be 235. So we have to wait our simulator until we reach 235 seconds to see the full curve. Here also you can manipulate the range of the voltage, so you can see the full graph like that. Yes, here also we need to change the time scale. Let's take like 10 seconds per division. Yes. Now as you can see, we are getting the exponential curve that we learned in theory. We have the voltage exponentially increasing with time. Where we will reach, where will be the maximum voltage? You have to know it. It should be 12 volt, the battery voltage. And how long would it take until we reach the maximum voltage? That is T, which is 5 times tau. Now we said that we have to wait 235 seconds to have the capacitor fully charged. Now I'll stop this video, then I will resume the explanation in the second video once my curve is ready, that my capacitor is fully charged.